Hey, how's it going? It's Mr. Farrell here. We're going to go over two more problems dealing with waves. Okay, both of these problems are going to use the period and frequency equation. Okay, so we did another video previously that used the wavelength, frequency, and velocity equation. All right, but now we're just focusing on period and frequency. We're going to do two practice problems, and hopefully this should be able to help you complete some of your homework. All right, so uh, let's go ahead and answer our or ask our problem. Put it on the screen. Oop, it's not looking for. Copy this. All right, so our question right now is the period of a wave is 12 seconds, and we need to figure out what the wave frequency is. All right, so for starters, we're going to go through and write out our ICE method. Okay, so identify, categorize, equate, and evaluate. Right, that's the method we use to solve our problems. Let's make some nice straight lines so we can separate each section. Awesome. All right, so for this problem, it is saying that the period of the wave is 12 seconds. So in our identify step, we're going to write down 12 seconds. All right, because that's one of the measurements that's mentioned in the problem. And it says, what is the wave's frequency? So it doesn't give us any other measurement. 12 seconds is the only one. And then it says, what is the wave's frequency? So we know we're being asked a question. So we want to make sure to put that question mark down. All right. So we've identified our measurements. Now let's go ahead and categorize them, which means write the symbol that represents that measurement. So the problem tells us that 12 seconds is the period. So we can put a capital T, which we use to represent period. We also know we're looking for a question, and that question is, what is the wave's frequency? So we can put F for frequency. All right, so pretty straightforward. Now we're already on to the equate step, where we write our equation that we're going to use to solve this problem. Now we've only discussed a couple equations so far, and the only equation we know that has F and T, right, frequency and period, is this equation. Frequency equals 1 over the period. Okay. Now, we chose this setup because remember, we don't know what the frequency is. So we want frequency to be by itself on one side of the equal sign. So this is set up for us to solve for frequency. All right. So let's go ahead and plug in our values. So we have frequency equals 1 divided by the period is 12 seconds. Okay. So 1 divided by 12 seconds. So we're just going to go ahead and throw this into the calculator. All right. 1 divided by 12 is 0.083 repeating, but we're just going to go ahead and cut it off at the 3. And let me double check that. Yep, that is the correct answer. And now we're looking for our units, okay? So our units, right now, we don't have any units in the numerator. We just have an S in the denominator, S per second. So we're gonna put our line and put our S right there. Now, remember, and this was something we've discussed in some of the other videos, when we're dealing with waves and we see that empty space above the S, we know that that's telling us waves per second, right? The blank spot means that something is happening per second. And it's blank because we don't have a unit for it. So whenever we see that blank spot, we can imagine that wave is supposed to be written there because it's waves per second, right? Because we're talking about waves. So when we see that our frequency is 0.083 waves per second, The other thing we know that we can do is whenever we see wave over second, that is the same thing as saying hertz, right? Hertz is our official unit of frequency. And whenever we see wave over second, we know, oh, we can just rewrite that as hertz. And hertz is what we want to write for our final answer. All right. We don't want to leave it as wave per second because we don't actually say wave when we're describing a measurement, right? We just put wave there as a placeholder to kind of remind us, oh, that's what we're talking about. And then when we see wave per second, we can know, oh, wave per second is frequency, that's hertz. All right, sweet. So wave per second means the same thing as hertz. So we've gone ahead and finished this problem. Let's go ahead and knock out one more. So in this problem, we solve for frequency. In our next problem, we're going to solve for the period, right? The period t. All right. So let's go ahead and put our new practice problem up there. All right. So our new practice problem asks us, a wave has a frequency of 2 hertz. What is the period of the wave? Okay. So let's go ahead and do our identify step. So the frequency is 2 hertz. So we see this measurement there. And then it says, what is the period of the wave? So immediately we go into a question. All right. So again, very simple problem in that we don't have a lot of measurements to identify. We just have 2 hertz and a question mark. All right. So we're going to go ahead and categorize these by writing the symbol that represents them. So we know that the problem said our frequency was 2 hertz. So we're going to write F for frequency. And then the period of the wave, we're going to put our capital T for period. Okay, that's what we're looking for. So now again, we're going to go ahead and use one of the equations that we have to solve for this. So I'm going to do this 2 different ways. The first way is the very simple way where you don't have to do any algebra, okay? The second way is going to be, well, the first way is not going to have the algebra. The second way, we're going to go over the algebra for those of you all who are interested. So for the first way, when we do our equate step, we're going to use the equation period equals 1 over frequency. Now, this is an equation that we have covered, right? But the reason why this is the easy way is because we didn't have to do algebra to get this equation, all right? So you can just go straight to this equation, having memorized it or written it down, and go ahead and plug in your values. Okay, so that's the easy way, all right? Now let's go ahead and do the hard, well, not hard way, but just the way that involves algebra. All right, I'm gonna make a little line between these two to separate them. All right, so now as we talk about the way that uses algebra, remember the equation we had to start with is frequency equals 1 over the period, all right? Now, I personally like doing it this way because when you do problems this way, you don't have to memorize a bunch of equations. You just remember one equation and you use algebra to change it however you need to in order to solve for what you're looking for. All right. So in this way, we're going to be using algebra. So we have frequency equals 1 over the period. All right. Now we are trying to solve for the period. And in order to solve for the period, we need to get t by itself, right? So currently it is 1 divided by t. So it's not totally by itself. We want it to be in the numerator as well. It is currently in the denominator. So we're going to have to switch some stuff around. So in order to flip t into the numerator, right, I'm going to have to multiply by its reciprocal, which is if this fraction is 1 over t, the reciprocal is t over 1. Okay, so I'm going to multiply this by t over 1. All right, I'm going to do that on both sides, t over 1. Now, what that does is it cancels out everything on this side of the equation. So we're going to be left with just 1 on that side of the equation. When everything cancels out, it just equals 1. That's really what happens. And on this side of the equation, we now have t in the numerator. Now, t is still connected to f, but at least it's in the numerator. So we're a step closer. So we have t times f, right? It's all divided by 1. But remember, when anything's divided by 1, you can ignore the 1. T divided by 1 is just t. Okay? So we've got t times f equals 1, right? Because again, everything got canceled out on this side. And we were just left with 1 divided by 1, 1, right? All right. So t times f equals 1. Now, in order to get to our final form of the equation where t is also now by itself, right? Because we need t to be by itself, we have to separate f. We need to remove f. So currently t and f are being multiplied by each other. So we're going to have to divide in order to separate them. Now, some people might look at this and say, oh, if we need to get t by itself, let's move t. So we'll go ahead and divide by t. But you don't actually want to do that, because if you divide by t, you're just putting t back on the other side of the equation, which we're not trying to move it back to the other side of the equation. We just moved it away from the other side of the equation to put it in the numerator. All right. So now we need to move the f away from it. Okay. So I'm going to divide so that I can do the opposite of the multiplication that's happening between t and f. And I'm not going to divide by t, I'm actually going to divide by f on both sides. And the reason is because, as you see, right, my f's are now going to cancel out. So if you are ever confused and you're like, okay, what do I divide by? Think about what you're trying to get rid of. Whatever you're trying to get rid of, that's what you're going to divide by. Okay. So after I divide by f, I'm left with the equation t equals 1 over f. Okay. So we ended up arriving at the same location. It's just using the first method, right? So using the first method over here, we had to remember this form of the equation, right? It's the same equation that we just used in the problem where we solved for frequency. We just have to remember this form of it, right? But in the second way that we did the problem, we used the same equation as last time, and we just rearranged it to solve for t. Again, I recommend that you practice the second way, because as you move forward in physics and math, you get a bunch of different equations, and you're not going to want to remember or commit to memory all the different forms of the equation. It's not effective, because it's just too much to remember unnecessarily, right? Instead, you can have the one equation and just practice the algebra that you need in order to rearrange the equation to solve for whatever you need. Okay, so definitely practice the second way. But if you're really trying to stay away from the math and algebra as much as possible, then you'll just have to memorize more equations. Okay. So in any case, we arrive at the same spot. So t, we're solving for t. It is by itself. It is in the numerator. It's all good. So now we're going to plug in our values in the equation. So our frequency was 2 hertz. Okay. So before we deal with the units and figure out what the final unit is going to be, let's figure out the final number. So here we have 1 divided by 2, which is going to be 0.5. All right, 0.5. All right, 1/2, 1 divided by 2. All right, now we need to figure out our units. So we know that we have hertz in the denominator right now. Remember, we can cross this out and say wave per second, right? That's what we have always been doing. Whenever we see hertz, we change it to wave per second, because it's a little easier to work with wave per second as opposed to hertz. All right. So we rewrote it as wave per second. Now, when we're figuring out the final unit, we've got to know a special rule. So the rule tells us that when we have a fraction in the denominator, we can move it to the numerator. You just have to take the reciprocal of the fraction. So let me repeat that. When we have a fraction in the denominator, we can move it to the numerator. We just have to take its reciprocal. So that means we have to flip it. So right now, we have a fraction in our units. We have wave per second. Now, remember, that is in the denominator of this problem, right? It's in the denominator. So in order to move it to the numerator, we just have to flip it. So instead of wave per second, it'll be second over wave, all right? So now we move this fraction to the numerator. All we have to do is flip it. So we're all good, 0.5 seconds per wave. Now to find out the final answer, we've got to remember that whenever we put wave as our unit, it's not because wave is an actual unit that we're using, right? It is just a placeholder. We put it there to remind ourselves what we're talking about. We don't actually want to put seconds per wave in our final answer. But wave is just like a placeholder that we're using to remind us that we're talking about wave. So whenever we go to write our final answer, we want to erase it or remove it or replace it with something else. So in this case, right, well, it's really just you want to replace it. So here, we're going to remove wave, right, because it's not an actual unit that we need to have there. It's just a placeholder for us. So we go ahead and erase wave. And as you see, we're left with seconds in the numerator. So our final answer, right? Let me just make this seconds look a little cleaner, right? So we were left with seconds in the numerator. So our final answer is 0.5 seconds, all right? And that is the period. So if it, and just to kind of walk through and explain this, if it takes, so the frequency was 2 hertz. So if it takes 2 seconds, or if 2 waves are produced every second, right? Because we can even tell from down here, hertz is wave per second. So if 2 waves are produced in 1 second, that means for our period, 1 wave is produced in half of that time, right? So if 2 waves are produced in 1 second, then it takes half a second to produce 1 wave, right? So you just divide how many waves you get per second, by, into the 1 second that you have. Hopefully that makes a bit more sense. But again, just briefly explaining that frequency is how many waves occur every second. And period is telling us how many seconds it takes to make 1 wave. So they both are ultimately going to agree, but as you can tell, they are the inverse of each other. So in this situation, right, if we make 1 wave in 0.5 seconds, because our period is telling us how long it takes to make 1 wave, then we'll make 2 waves in 1 second, right? Which is our frequency, 2 waves per second. So that's how it kind of relates to each other. Again, if our period is telling us we make 1 wave in 0.5 seconds, then we know we're going to make 2 waves in 1 second. And our frequency up here is telling us just that. We make 2 waves per second, all right? 2 hertz. That's what wave per second is. All right, sweet. So hopefully this helps you complete some more of the problems that we've been going through in class and on homework. And hope you have a good one.